Hello class, so today we're doing lesson 10.5, the surface area of pyramids. So just like we did in our previous lessons, we're going to be going over surface area of our shapes. Pyramids are very similar to triangular prisms, however, they've got some differences. So I want you to copy this down in your notebook. A pyramid is a three-dimensional figure with at least 3 triangular sides that meet at a common vertex, and only one base, and that base is a polygon. So that's really important to note. The triangular sides of a square pyramid are called the lateral faces, and the slant height is the height of each lateral face. So these are the kind of things that you're going to be seeing. Now, vertex, we're going to think about that as it's got at least 3 triangular sides that meet at a common vertex. So as such, which part of here do we think the vertex is? Perfect! So where they all meet, right there, that's what our vertex is. Then let's think about it. When we're talking about our height, we've typically seen it like this with our little right angle. So if that's the height, here we're going to refer to it as the slant height. And then lastly, this here, it's not a very clear arrow, but it's talking about this right here. So it's talking about that triangle or any of them. What do you think that vocabulary word is going to be? Is it a base that's the polygon? The whole thing is a pyramid. So that means that this has to be a lateral face. Excellent. So make sure that not only do you have this section in your notebook, but I want you to complete this section on page 783. So here's our real world link. Claude made a model of the large pyramid in front of the Louvre Museum. His model is shown. So it's asking us to draw the faces of the pyramid as the base. It's a square. And the lateral faces, they are all the same things like that. Now, I've been to the Louvre, and it's actually very pretty. I went there when I was in summer long ago, back in 2015. At that point, I had had a couple of jobs in my life. When I went there, I was currently working at a place called the Thermography Center. I want you to copy this into your notebook. The surface area of a pyramid is the sum of the area of the base and the areas of the lateral faces. Exactly the same thing. We're talking about surface areas. We're just adding up the areas of the two-dimensional shapes. So right here, this exactly shows what we saw on the other page, and this is how it shows it decomposed. Now, here's something that you really need to pay attention to. Some pyramids have a square or rectangular base. Notice it says some. I also want you to copy this down. A triangular pyramid has 1 triangular base and 3 triangular faces. If the base is an equilateral triangle, all 3 lateral faces are congruent. Congruent means equal. If the sides of the base of the triangle are different lengths, the area of the lateral faces will also vary. So those are the 2 types of triangles we have. Make sure you copy that into your notebook. We're going to look at this example. Here's one where we have a regular surface area of the pyramid. It is not a triangular-based pyramid. It is a square. So we look here. We're going to use a net to find the area. So when we look at this, as I already see at the bottom, we've got this part right here, which is 7 times 7, or 49. Then each of these triangles has a length of 7 and a height of 9. we've got 1/2 of that because it's a triangle. So we get 31.5. But we have 4 of those. So we have 31.5, 31.5, 31.5, 31.5 plus that 49 center to get 175 square centimeters. This reminds me of when I used to work at the Sunglass Hut because of all of these shapes and fancy cool things that we would see on the corner of sunglasses. Let's look at example 2. So for this one, it's a triangular pyramid. If you notice, this one kind of looks more, we've got that triangle at the bottom, all of that stuff. So they decompose it for us. The base is 4 feet. Our height is 3.5, but we know that all of the sides are 4 feet, it shows, which means it's an equilateral triangle. And we see to be confirmed, all 3 of these are the exact same, just like it says in our thing. So the area of the base for a triangle, it's 1/2 base times height. 1/2, base is 4, height is 3.5. 1/2 of 4 is 2. 2 times 3.5 is 7. The area of each lateral face. Each lateral face is 1/2, the base, 4, and the height, 5. 1/2 times 4 is 2. 2 times 5 is 10. Then we have to add them together to find the surface area. We already know this. It tells us here, all 3 sides are 4 feet long, and we've got a base, which means there's 4 things we're adding. We see these 4 pictures. Here we had 7, 10, 10, 10. So we know our answer is going to be 37. And let's look at the bottom here. We've got 7 plus 10 plus 10 plus 10, so 37 square feet. Excellent. This is making me hungry, just like when I used to work at Jersey Mike's. Here's a fun one. A pyramid puzzle has all sides that are equilateral triangles. That's super helpful. Every single one of these is an equilateral triangle. That means they're all the exact same. So we're only going to care about one and count it 4 times. Each triangle has a side length of 8 centimeters and a slant height of 6 9/10 centimeters. Find the surface area of the puzzle. So each face has an area of, and it's a triangle, which means it's going to be 1/2. Our base is 8, and our height is 6.9. 1/2 times 8 is 4. If we did this up here, 4 times 6.9. 4 times 9 is 36. 4 times 6 is 24. We get 27. We bring our decimal. So we get 27 6/10 square centimeters. So the surface area of the puzzle is 4 times that because we've got 4 of those triangles, or 27 6/10 plus 27 6/10 plus 27 6/10 plus 27 6/10. We add them all together or we multiply and we get 110 4/10 square centimeters. So I want you to go to page 484, 485 and do problems A, B, C, and D. Make sure you hit pause here so that you aren't just watching along. Let's look at A. So here we have a pyramid that has a square base. I'm going to deconstruct this and we're going to break it into parts. Now, what we know is this base has 16 by 16. As such, all of our triangles are going to be the same. So we have one base that's 16 by 16, and we've got 4 triangles that's 16 by 12. So let's do our math. 16 times 16. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. Magic 0. 1 times 6 is 6. 1 times 1 is 1. 6, 5, 2. We get 256. Then, for our triangles, it is 1/2 base times height. 1/2 times 16 times 12. I'm going to cancel that out. It gets 8 times 12. 8 times 12. Let's do that math up here. 8 times 2 is 16. 8 times 1 is 8. We get 96. So each one of these triangles is 96. But we have 4 of them. So now what we have is 256 plus 96 plus 96 plus 96 plus 96. And instead of doing that repeated addition, let's just make it 4 times 96. I want to make our lives easy. I always want to make our lives easy. So we got 96 times 4. 4 times 6 is 24. 4 times 9 is 36, plus 2 is 38. So now we have 256 plus 384. We add those together. We get 640 feet squared. Excellent. Let's look at B. Again, here, our square at the bottom is 3 by 3, which means all of our sides are the same. So I've got one square, 3 by 3, and I've got 4 sides, 3 by 4 and 5/10. So 3 by 3 makes 9. Plus, and I know that all of my sides are going to be the same, so 4 times. And let's see, that's 1/2 times 3 times 4 and 5/10. Now, once again, I'm lazy. I don't want to do this. I change that to 9 plus 2 times 3 times 4 and 5/10. So let's check that out. 2 times 3, that's 6. 6 times 4 and 5/10. We get 6 times 5 is 30. 6 times 4 is 24. Plus 3 makes it 27. And we have our 1 over there. So 1 here. So we get 9 plus 27. And 9 plus 27 is 36 inches squared. Excellent. Not so hard, is it? Problem C. So here, what we see is luckily we have an equilateral triangle. So we see that this side is 2, that side is 2, and that side is 2. So I'm going to draw my first triangle. So 2, and we've got our height, which is 1.7. Since it's equilateral, we know that all of our lateral faces are the same. So we've got 3 of these triangles with, again, a base of 2 and a height of 3.5. So let's find our area. For this one, I have 1/2 times 2 times 1 7/10. That goes away. It's just 1 7/10. Then, for this one, I have 1/2 times 2 times 3 5/10. That goes away. I have 3 5/10. So, the fact now is I have one base, which my base was 1 7/10. And then I have 3 lateral sides. So 3 times 3 5/10. So I'm going to do the multiplication. 3 5/10 times 3. 3 times 5, 15. 3 times 3 is 9. Make it a 10. Move it back over. So we get 1 7/10 plus 10 5/10. What we get, let's line it up. Remember, we always line up our decimals when we add. Is 12 2/10 centimeters squared. Excellent. Remember, if I'm ever going fast, hit pause and do the math on your own. It helps if you do, not just if you watch. Problem D. Again here, what we see is we have an equilateral triangle. Yes, that makes our life so easy. 6 by 6 by 6. So I've got one triangle here. My base is 6. My height is 5.2. That's my base. So I only have one of those. Then I've got 3 triangles here with my base is 6 and my height is 8.3, 8 3/10. But I've got 3 of those. So let's see what our area is. For here, it is 1/2 base times height. That goes away. It's 3. 3 times 5 is 15. 3 times 0.2 is 0.6. 15.6. That's our base. 15 6/10. And then I know I'm going to have 3 times because I've got 3 of those other sides. Let's see here. 1/2 times 6 times 8 3/10. That becomes 3. 3 times 8 is 24. 3 times 0.3 is 9. So I get 24 9/10. Once again, now we got to do some more multiplication. If you can't tell, this unit is pretty big on multiplication and addition. So we got 24 9/10 times 3. When we multiply, we always line up at that far right. 3 times 9 is 27. 3 times 4 is 12. Plus 2 is 14. 3 times 2 is 6. Plus 1 is 7. We moved it over 1. We move it back 1. So we now have 15.6 plus 74.7. We line that up. 74 7/10 plus 15 6/10. And we get 90 3/10 meters cubed. Excellent! I want you to do the guided practice numbers 1 through 4 on page 786. Let's look at number 1. Excellent. Here, we have a square. It's 4 by 4. So let's deconstruct it. We have 4 by 4. As such, because it's equal, we know we have 4 of the same shape of our triangles. Our triangle is 4 by 6. So let's do our math. 4 by 6, that's going to be 1/2 times 4 times 6. That's 2 times 6, or each face is 12. Here, the bottom is 16, 4 by 4. So I have my base, which is 16, plus, and then each of my sides is 12. How many sides do I have? Let's count. 1, 2, 3, 4. So I multiplied it by that 4. 4 times 12 gets me 48. And then I'm going to add to that my base of 16 to find my total surface area. Let's add 6 plus 8 is 14. We get 64 inches squared. As we can see, this lesson's not that hard. It's just a bit time-consuming. Number 2. Again, we have our nice equilateral base. These are always super helpful for us. So we have our square that's 8 by 8, and we have 4 faces that are 8 by 10 7/10. So when we do this, 8 times 8, our base is 64, plus, then we have 4 times, because there's 4 faces, 1/2 times 8 times 10 7/10. Boop, boop. That just becomes a 4. Now, we can multiply all of these together in any order at the same time because it's just multiplication. So we have 4 faces times that 4, which is the 1/2 of 8, times that 10 7/10. I want to make my life easy. I already know that's 16. So I'm going to make it 16 times 10.7. Line it up at that far right. Move my decimal that way. 6 times 7 is 42. 6 times 0 is 0. Plus 4 is 4. 6 times 1 is 6. Magic 0! 1 times 7, 7. 1 times 0, 0. 1 times 1, 1. Add it all together. 2, 1, 7, 1. Let's add that 64 in just for good measure. And now we get 1, 7, 7, 6. But if you were paying attention, I forgot to do something, and I made a mistake. This is why you always want to call Miss Diaz out on her mistakes. I moved this over 1, so I got to move it back 1. So my answer is 171 and 2/10. See, this is what happens when I go too fast. So now I've got to add these together. We line up our decimals. So we get 171 and 2/10 plus 64 and 0. And we get 235 and 2.2 meters squared, which makes a lot more sense. Here's this last one of the drawings. Once again, it is an equilateral triangle at the bottom, and we only have those 3 sides. So we got one triangle. That's 5. The height is 4 and 3/10. Then we've got 3 of these triangles with the base, as we know, is 5, and the height is 6. So for these, we have 1/2 times 5 times 6. Cancel those out. We'll make it a 3, which is this. Each of the faces are 15. And how many faces do we have again? 1, 2, 3. So we have 3 of those faces. So now I've got 3 times 15. 3 times 15? We get 45. So let's find the height of the area of my base, and then I'll be good to go. 1/2 times 5 times 4 and 3/10. This one I can't do much cancellation, so I'm just going to have to do my math. So I know if I do it in my head, I can do the cancellation, but let's not risk it for those of you who don't know how to do it. So 5 times 4 and 3/10. Move my thing back, so I'm going to have to move it back in the end. 5 times 3 is 15. 5 times 4 is 20. We get 21. So we get 21 and 5/10. Then we have to divide that by 2. That's the same as multiplying by half. So 2, 21 and 5/10. It goes in 1 time. That's 2. Goes in 0 times. That's 0. Oops, that's supposed to be a 1 right here. Then we bring down here. It goes in here. It goes in 7 times. That's 14. We have a 1. We bring down our next 0, and it goes in 5 times. So for this base, we get 10.75, or 10 and 75 hundredths. So we got to add that. We got 10 75 hundredths. We line up our decimals plus 45. It's pretty easy. 55 and 75 hundredths centimeters squared. Excellent. So last for the guided practice. Pyramid-shaped gift boxes have square bases that measure 5 inches on each side. Excellent. Here, 5 by 5. The slant height, so our height, is 6.5. Excellent. How much cardboard is used to make each box? So when it's got a square base, we know that we have 4 sides. So let's make it out. Here, our base is 25 because 5 times 5 is 25. And then let's figure out what each of our faces are. There's 4 of them. We have 1/2 times 5 times 6 and 5/10. So let's do our math together. 1/2 times 5 times 6 and 5/10. I'm going to do my bigger numbers first. You can do it in any order. 6 and 5/10 times 5. Move it over once. I'm going to move it over when I get back. 5 times 5 is 25. 5 times 6 is 30. 32. So I get 32 and 5/10. But now, because I have that times 1/2, I have 32 5/10 that I have to divide into 2 parts. same as multiplying by 2. 2 goes into 3 one time. That's 2. 2 goes into 12 6 times. That's 12. Bring our decimal. 2 goes into 5 2 times. That's 4. Bring our next 0 down. 2 goes into 10 5 times. So now each of these faces is 16 and 25 hundredths. I've still got 2 more steps to go. I got to figure out 16 and 25 hundredths times 4 because there's 4 of them. Move, boop. I'm going to move it back. Boop, boop. When I'm done. 4 times 5 is 20. 4 times 2 is 8 plus 2 is 10. 4 times 6 is 24, plus that one we get 25. 4 times 1 is 4, plus 2 we get 6. So I move that back, and I get my answer to be 65. Now I get 25 plus 65. Let's write that. We'll do up and down math. 65, 25, we get 90. So our answer for how much cardboard is used to make each box is going to be 90 inches squared. Excellent. Your homework is going to be page 787 and a tiny bit on 788, numbers 1 through 10. Thank you, guys.